All right, so we were on our notes. We had already done covalent, which we use as a prefixes, and then we were on ionic. And we did the part on ionic where you're given the formula and you write the name, but we haven't done the other part. So that's what we're going to look at now. If I have the name and I have to write the formula, and it's a little bit more difficult because you don't have the prefixes to tell you what the subscript is. You have to decide what the subscript's going to be. All right. Let's see if I make this a little bit bigger. All right, so we're writing our our formulas for an ionic compound, which is a metal and a non-metal. We always write the cation first, the metal ion first, and the anion or the non-metal second. So you're always going to have your metal first, and it'll be a positive ion. And then you have your non-metal, which will be a negative ion. And your metal and your non-metal need to be combined so that when you add up their charges, so your metal and your non-metal need to be combined so that when you add up your charges, you'll have an overall neutral compound. So that means your positives have to be equal to your negatives. And that's what you do by describing what the subscript is. So with overall charge must be 0. It is neutral. Tyreek, we're on our notes right now. We're at the top on the first page, on the back at the top is what we're working on.
Okay.
And you're going to be using your ion list that you have to look at the charges. Once again, you don't have to memorize them. All right, so let's say that I had a formula. I had sodium chloride. The first thing that I'm going to do is I'm going to look on my ion sheet and I'm going to find out what their charge is. Sodium is in group 1, so it's a +1. And chloride is a halogen in group 17, so it's a -1. This is going to be easy one. My positive is already equal to my negative, so that means I just need one atom of each. So my formula would be NaCl. If I use one atom of sodium, that's a +1. If I use one atom of chloride, that's a -1. So my positives are equal to my negatives, and it's neutral. But obviously, it's not always going to be that easy. If I did this one, aluminum is a +3. And once again, you don't have to memorize those ion numbers. You get those off your ion sheet. Oxide is a -2. They're not equal to each other. So we're going to have to give something a subscript so we can get them equal to each other. So what's the smallest? Kind of don't worry about the negative sign. What's the smallest number that 3 and 2 will both go into? 6. So I'm going to try to get 6 on each side. So I'm going to put my Al for aluminum. What do I need to multiply 3 by to get 6? 2. And then I'm going to put my O for my oxide. What do I need to multiply -2 by to get 6? 3. And then that would be my correct formula. If you look at it, it's like the charges switch places, but you would never have, but you leave the negative sign behind. You would never have a negative subscript. But if you look at it, that 2 came over here and became the subscript for aluminum. That 3 came over here and became the subscript for the oxide. So that's what makes it a little harder. You have to determine which one it's going to be. So let's just work through a couple more. Here I have magnesium is a +2. Phosphide is a -3. So once again, we have that 2-3 combination. So what are we trying to get to? 6. So I put Mg, my symbol for magnesium, and what would its subscript be? 3. And P for phosphide, and it would have a 2. And that would be my correct formula. Not too bad. Calcium is a +2. Oxide is a -2. When they're already equal to each other, do I need to give them subscripts at all? Nope. I just put CaO. Now remember, when you have that number in parentheses, that tells me what the charge is of the metal or the element right before it. So this tells me it's a +2. It's kind of like a little cheat sheet. I don't even have to look at my ion sheet. Iodide is a -1. So they're not equal. So I start off, I put my symbol for copper. It's already at a +2. So does it need a subscript? No. Then I put my I for my iodide. It's a -1. So what does it need a subscript of? 2. Because then it'll have 2 times -1 will give me -2. Once again, if you think of them as crossing, copper would get the 1, but we never write a 1. Iodide would get my 2, and I do write a 2. So it's like the charges switch, but you would never write a 1, and you would always make them positive. All right, let me get some of this out of the way. Now, if we have a polyatomic ion, because remember we use those on the bottom. So aluminum is a +3. If you look on your ion sheet, sulfate is a -2. So once again, I got that 3-2 combination. So aluminum is going to need a subscript of what? It already 2, exactly. And my sulfate is going to need a subscript of what? 3. So I have to get my sulfate off of my polyatomic ion list. I have to put it in parentheses. So if you look there, sulfate is under the -2 column. It's SO4. So I write all that down, put it in parentheses, and put my 3 on the outside of that. So it might be a good habit for you if you take something off the polyatomic ions just to automatically put it in parentheses. That way, if you do a subscript, it'll be correct. If you don't do a subscript, it's not incorrect if you have it. All right, copper is a +2. Acetate's a -1. So once again, if I think of them as switching, Cu, would it have a subscript? No, because we don't write a 1. And then acetate is up here under your -1 box. C2H. You would put that in parentheses. And then on the outside, what was its subscript that it needed? A 2. Why don't y'all give those 5 a try right there? We'll take a minute and then I'll come back and work through them. So try your iron of those 5 right there that are the other examples. And then what did I do with my pen? So I lose my head if I don't touch them. All right. So these last few ones, iron. Remember this right here tells you it's a +2. That doesn't tell you what the subscript. And -1. So what would my formula be?
1.
But remember, we don't ever put a 1, so we just assume it's there, right? And then BR2. This one, you're right, it came over to the iron, but we don't write a 1. We just assume it's there. +1 minus 2. So I would have Na, what would the subscript be? 2. And then S1, but we don't write 1. So it would stay like that. This is a Roman numeral for 4. So this is +4 and nitride is -3. So once again, they're going to exchange. So my lead Pb would now have a 3 and nitride would now have a 4. And that way they would have +12 on one side and -12 on the other side. Potassium chlorate is, let me get some of this out of the way. Okay, potassium is a +1. Chloride is a -1. So they're already equal. So all I need to do is write them down. K is potassium, and if you look for chlorate, it's ClO3. That whole thing makes up the chlorate. You can leave it out of parentheses, or since it's a polyatomic ion, if you want to put it in parentheses, you also can do that. Lead, right here, it tells me it's a +2. I don't even have to go to my sheet. It's like a little cheat sheet. Nitrate is a -1. So they're going to switch places. So Pb, will it have a subscript? No, because it's a 1. We don't write 1. Nitrate is NO3. I got that off my ion sheet. And because I'm going to have to give it a subscript, I have to put it in parentheses. So what is its subscript going to be? 2. All right, not too bad. So if y'all finish up your second half of that worksheet, I think maybe there's 10 problems or so on there. It's not a whole bunch. And like I said, we probably will hold off doing anything tomorrow since so many are gone, and then we'll move on to naming acids next couple of days. We will have a quiz over this on Friday.